For 40 weeks, the human body pulls off something pretty incredible. It nurtures a whole new life while keeping these powerful uterine muscles completely, totally calm. And then, almost like clockwork, a switch flips, and the whole process of childbirth, what we call parturition, kicks off.
So how in the world does that happen? How can the uterus be this perfectly peaceful home for months and then so decisively just switch gears and start labor? It's one of the most fascinating puzzles in human physiology, and the answer? Well, it's a masterclass in hormonal control.
You see, the secret isn't some simple on-off switch. No, it's much more like a complex and honestly beautifully coordinated hormonal ballet. It's a whole story of chemical messengers, of brakes and accelerators, all working together perfectly to manage this 280-day countdown.
Okay, so to understand how labor starts, we first have to get our heads around how it's prevented for 9 whole months. And that brings us to our first major player, something called the progesterone block.
Think of the progesterone block as the body's ultimate peacekeeper. For most of the pregnancy, the hormone progesterone is completely in charge. Its #1 job is to keep the uterus quiet and prevent it from contracting, creating the safe, stable nursery for the fetus to grow. What's really going on here is a kind of hormonal tug-of-war. The body is already making oxytocin, a hormone that causes super powerful contractions. But all through the pregnancy, progesterone's main goal is to block its effect on the uterus. Progesterone is the brake on the system, making sure those contractions just don't happen.
And while progesterone is busy keeping the peace, it's also helping the body get ready. The uterus goes through these massive changes. Get this, its muscle fibers constrict up to 11 times their original length. The body also goes into a state of positive nitrogen balance, which is perfect for building all this new tissue. And it holds on to more water for the baby, the placenta, and all that extra blood volume.
So you might be asking, what makes sure this progesterone brake is on from day 1? Well, right after implantation, the embryo starts producing a hormone called human chorionic gonadotropin, or HCG. Yep, that's the hormone they look for in pregnancy tests. Its job is to tell a little structure in the ovary, the corpus luteum, hey, keep pumping out that progesterone to maintain that crucial block. For about 38 weeks, this whole system works perfectly. But as that due date gets closer, the entire strategy shifts. The body moves from just maintaining the pregnancy to actively preparing for birth. This is the hormonal tipping point. And the main trigger for this big shift? It's the placenta itself. After months of really hard work, it just naturally starts to age. And as it gets older, its output of hormones, especially our peacekeeper, progesterone, starts to drop off.
This is a massive change in command. All through gestation, high progesterone keeps the uterus quiet. But at term, when those progesterone levels fall, the balance of power completely shifts. The uterine muscle suddenly becomes irritable and excitable, and that sets the stage for labor to begin.
And this really gets to the heart of it. It's not about a new hormone suddenly appearing to start contractions, no. Instead, as the source material puts it, it's the withdrawal of progesterone's inhibitory effect that allows these coordinated squeezing movements to finally begin. The brake is being released.
So, with that progesterone brake finally released, it's time for the accelerator to take over. And this is where oxytocin, a hormone that's basically been waiting in the wings this whole time, finally gets its moment to shine.
Now that it's unopposed, oxytocin can hit the uterine muscle with its full force, starting those strong, rhythmic contractions that we know as labor. The system has officially been given the green light.
And this is where things get really dynamic. As contractions push the baby's head down onto the cervix starts to stretch. That stretching sends a signal all the way up to the brain, which responds by telling the pituitary gland to release even more oxytocin. More oxytocin means stronger contractions, which means more cervical stretch, which means, you guessed it, more oxytocin. This incredible positive feedback loop is called the Ferguson reflex, and it's what drives labor all the way to the finish line.
You can really see how it all comes together in this diagram. The withdrawal of that progesterone block lets the contractions begin. That causes the cervix to stretch, which triggers the brain, specifically the hypothalamus and posterior pituitary, to release oxytocin, kicking off that powerful feedback loop. It's a beautifully coordinated effort. But hey, oxytocin isn't doing all the heavy lifting alone. There's another key hormone with the perfect name, relaxin.
It's secreted by the ovaries and the placenta, and it helps out by softening the cervix and relaxing the pelvic ligaments. Basically, it helps enlarge the birth canal to make the baby's passage that much easier.
All right, let's bring this all home. That initial paradox, how the body can both hold on to a pregnancy and then end it so precisely, it's all resolved through this beautifully timed hormonal finale.
You can really think of it like a hormonal relay race. For the first 3 trimesters, progesterone is holding the baton, keeping everything stable. At the end of term, it passes that baton by withdrawing its influence. And then, oxytocin grabs it and takes off for the final sprint, driving labor to completion.
So the crucial thing to take away from all this is that parturition isn't triggered by a single on-off switch. It's a cascade. It's the result of all these interconnected events: the aging placenta, the fall of progesterone, the rise of uterine excitability, and that powerful oxytocin feedback loop, all working in perfect sync for a smooth delivery.
I mean, when you step back and look at the whole picture, it's just a masterpiece of biological engineering. The body's ability to use these simple chemical messengers to manage such a complex, long-term project with such a precise conclusion is truly remarkable. It really leaves you with a final thought. What does this intricate dance teach us about the sheer